Did I break it?
No. Is it turned on?
Yes, it's turned on. Why isn't it working from here?
I don't know.
Okay, reoccurring question. Why is the sun the center of the solar system? Who thinks they know? Anybody? Yes.
Because it has the most mass.
Perfect. Because of its intense gravity. And why does it have intense gravity? Because of its mass. And how much mass does it have? Does anybody know? And what percentage of the solar system's mass does the sun hold? Percentage, 0 to 100. 99.8%. Yeah. So when you think about Jupiter, massive Jupiter, Mars, Mercury, Earth, all the asteroids, all the dwarf planets, everything, all the mass that there is in the solar system, the sun makes up 99.8% of it. So that's why the center of the solar system. Okay? And I'm going to ask that question annoyingly like 4 or 5 times. Okay, so first we're going to go over rotation and revolution. The reason why this is hard concept for students is because we don't use it in our everyday language. I'm sure in past classes your teacher would say, okay, now rotate your tables or rotate your sensors. But you don't actually rotate, you revolve. If you rotate it, you just be doing this. Is that what you do? No, okay. So your classmate, I'm sorry, I forgot your name. Key, stay back there. Key and I both have a ball to demonstrate this. Y'all know what this is, right? Elena is the math? Okay, this is what? X-axis? X-axis, right? And a Y-axis, right? Okay. So this is all what rotation is. The Y-axis, or the point at which it rotates, is in the center of the object that you're talking about. So Earth rotates or spins on an axis. It's an imaginary line between the North Pole and South Pole. And again, the rotation requires the axis to be on the inside. So if you hold up the ball back there, you can watch me right now, and I'm going to let this ball go. And if you can see, if you imagine that in the very center is where everything is rotating. It's not really moving, is it? It's just spinning. It's all in one place. So that's rotation. That's what the Earth does.
Is this string getting longer?
Huh?
Is this string getting longer?
Yeah, it's uncoiling. It's letting go of its kinetic energy. So that is rotation. Revolution, however, is an orbit. It goes. Good Lord. Sorry. Another technical malfunction. Okay, I see what's happening. Okay. Is there a way to expand this to full screen on the monitor?
That's expanded.
Okay.
Yeah, because
that's what it is. I keep moving it off the screen on the computer over there, and that's
okay.
I keep it very still. So on here we got the sun has the axis, and the X and Y axis, and the sun, and the Earth is rotating around the axis. So the point of revolution is outside the revolving object. You see that? Where the object is revolving, the point of where it's moving is outside of the object. So revolving almost requires a second object, and revolution and rotation doesn't. So we did the tennis ball one, and then let me see here. Okay, we did rotation. So here's revolving. Y'all remember when we did our experiment about inertia?
Yeah.
Okay, where's the two objects? The ball's one.
And
the hand. Okay, so that's revolving. Okay. So let's talk about how that applies to the moon. Who knows this? Who knew this? The moon faces the Earth the same. The moon has the same face towards Earth at all times. We never see the backside of the moon. You knew that? Anybody else know that? Okay. Who thinks that who thinks the moon is rotating? If we're always seeing the same side, do you think the moon's rotating? Okay, raise your hand if you think the moon is not rotating. No? Okay, that's a very hard concept. This is actually took me a little bit to actually focus and understand. So I need a volunteer from this table. Okay. You look.
no, I'm just
There you go. Can you hold that for me? Can you stand that and hold Okay, I'm gonna be the moon. Noah's gonna be the earth, and we know what this red string is, right? Can you hold it high so we don't
The
decapitate
red
anybody?
string.
Remember from our last experiment, what's the red string?
It's the
Gravity, there we go, okay. So, I'm the moon, right? He's the earth. This is a makeshift orbit because the classroom isn't really set up. I'm still looking straight, I haven't showed my back to him, have I? Okay. Y'all get the idea, right? This is what the moon's doing. I'm rotating around the earth, okay? The gravity, the distance really doesn't change that much, okay?
So the moon and the.
So did I rotate? I revolved, right?
Yeah.
I still need you to hold it, okay? I did revolve, okay? So, now I'm gonna do it one more time, okay? But there's gonna be something slight different, okay? Watch.
You're going slower.
Nope.
You're not turning.
I'm what?
You're looking the same direction.
I'm not what?
at all
Someone said it over here.
You're looking.
I'm not spinning. Where was I last time? Where was I facing when I was here last time?
Facing the earth.
I was facing him. So did I rotate that time? No, I did not rotate that time. I rotated the first time, yes. It's very tricky concept. So who thinks they know what happened? I rotated and I revolved. Why was it so funny? Out of the ordinary. Go ahead.
The first time or the second time?
The first time.
Oh, because you're like kind of always facing it and not yet, but just going in circles.
Mm-hmm. But that's not how it works with the sun and the earth, is it?
No.
No, it's not at all.
Why?
It's very, let me see, did I put it here? Oh, no, I didn't. Okay, I didn't. I don't want to explain. That's what, because the amount of time it takes the moon to spin or rotate, is the same amount of time it takes to move around the earth. They both take 28 days. It takes 28 days for it to spin, and also takes 28 days to move around the earth. So that's what they call tidal walking.
I'm so.
It takes 28 days for the moon to go around the earth. Yes.
That makes no sense.
Yeah, it does.
Well,
No, that's how
are you
long the
saying
earth
that-
takes to spin around. Yeah. Yeah, that's the day. Yeah. It's okay. It's very confusing because you got different objects acting different, similar ways, but they all have different effects just because the time is slightly off. Okay. So again, the sun's the center of the solar system because of intense gravity. What gives the sun gravity?
It says mass.
How much mass in the solar system does the sun have?
99.98.
I told you I was going to be annoying with asking that question. Solar system history. This is pretty interesting, I think. So I put this in this geocentric model. It's geo means